So we have introduced the notion of the Cartesian coordinate systems and also the notion of the three unit vectors. Okay, so now it is time that we understand that how we represent any given vector in terms of these three unit vectors, the x cap, y cap and the j cap, or the more commonly used I cap, j cap and the k cap. So let me try to give you a brief recollection of what was told in that video of the Cartesian coordinate system. So if this is your Cartesian coordinate system, remember we use the right hand one, that is if x cross y is done, again you don't know the cross product presumably till now, so I will teach you the cross product and the right hand screw rule back then, but for now remember that x, when you go from x to the direction of y and you have your thumb pointing towards any direction, then the thumb must point towards the z direction, the positive z direction to be exact. So I think I have to launch a short video in order to show you how this right hand corkscrew rule or right hand screw rule, whatever you would like to call it, works, if you want to understand that what is meant by the right handed coordinate system and how can we actually determine the direction of what is known as a cross product. So this will be covered in upcoming videos, don't worry. So basically you take the Cartesian coordinate system like this, the x, y and the z, and what you do is you define three unit vectors. This is the unit vector along the x direction, it is known as the I cap vector. This is the unit vector along the y direction, this is known as the j hat vector or the j cap vector, and this is the unit vector along the z direction, this is known as the k cap vector. Okay, you can also do x cap, y cap and z cap, but I, j, k are the more common or more used notations. Okay, so I cap, j cap and the k cap, since these are unit vectors, of course the magnitude of these vectors are 1 individually. So this has a magnitude of 1, this has a magnitude of 1, this has a magnitude of 1. Okay, and these vectors typically do not have any units. Okay, now that is something that might not come out as very natural or very common, because vector is a physical quantity and a physical quantity should have a magnitude and a direction, but the role of the unit vectors is to simply give you the direction. Okay, therefore unit vectors seldom have units, physical units. Okay, so unit vectors are termed as unit vectors because their magnitude is 1 and they are simply used to give you an idea about the direction of any particular vector. So basically you can represent any vector, let us say a force vector, in terms of the unit vectors I, j and k. So we write that f vector is fx I cap, fy j cap and fz k cap, and since force is a vector quantity or a physical quantity, we also write the unit of force, which is Newton. Or there is another unit of force which is also known as dyne. We are going to talk about these units when we are studying Newton's laws of motion. So fx, fy and fz are known as the components of the force along these directions. So let me try to write down the word components of the vector f. So fx, fy and fz are known as the components of the vector f, and fx is known as the x component of the vector f, fy is known as the y component, I'm writing in short, of vector f, and fz is known as the z component of vector f. Okay, so components is a new word that we have learned in this video. Okay, so components of a vector are typically the part of the vector that lies along the direction. So the vector f vector, if there is a force vector like this, okay, this is the f vector, then we can typically resolve this f vector into three directions. Okay, you know that if you have a position vector, then you can drop a perpendicular on the xz plane, and then you can use this plane in order to give you an x component and a z component, and the y component can be obtained like this. So this component that you obtain is the fy, this component that you obtain is the fx, and this component that you obtain is the fz component. And this fx, fy and fz are typically magnitudes only, and when these magnitudes are multiplied with the corresponding unit vectors, they become vectors themselves. So fx is not a vector, but fx I cap is definitely a vector. Fy is not a vector, but fy j cap is a vector. Fz is again not a vector, but fz k cap is also a vector. And if you add these three vectors, you get the actual vector or the total f vector. This addition of course follows the law of vector addition. Okay, so when you solve a lot of problems, you will come across these situations, and after you use it for a considerably long amount of time, you will find out that yes, this is obvious and this is how it works. Okay, so for now I have simply introduced to you the notion of the unit vectors and representation of any vector in terms of the unit vectors. I can also give you another example, but again it will be simply the same thing in a different language. Okay, so let me try to give you one application. For instance, if you want to find a force that is negative of that force, that is some force which actually it has the same magnitude of the f vector and acts in a direction that is opposite to the f vector, then you simply say minus f. Okay, we have learned this, that using a negative sign in front of the vector reverses the direction of the vector. So minus f can be written as minus of fx I cap, fy j cap plus fz k cap. And then you say this is minus fx I cap minus fy j cap minus fz k cap. Now you have to hold on a little bit. I told you that fx, fy, fz are nothing but magnitudes. Okay, length is a magnitude, so there is no concept of negative length. Okay, so whenever you have a negative sign in front of a vector, then the only thing that you can do is adjust that negative sign or associate that negative sign with the direction of the vector. Therefore, you have to write this as fx minus I cap, fy minus j cap, and fz minus k cap. Okay, so if this direction is I cap, then of course minus I cap will be the negative x direction. If this direction is j cap, then of course minus y direction will be negative j cap, and of course that direction will be negative z cap, and therefore this force will get reversed. And if you want to have a look as to how it will get reversed, then let me erase all these things once and draw the f vector originally, and this how it looks. So again, this is maybe will be the fx component, but in the negative I cap direction. This will be fy, but in the negative j cap direction, and somewhere at the back you will also get an fz and along the negative z direction. Of course, this is a 2D plane and it is impossible to draw a 3D diagram with maximum quality and clarity on this plane. Okay, so therefore maybe I will use a simulator in order to show you how it works. Okay, but for now I hope that the basic notion of using the unit vectors to represent a vector is clear to you. And just as I have shown you how the negation of the force vector works, I will conclude this video by showing you just how the multiplication by a scalar works. So if you have, for instance, n f vector, then again you multiply this whole right hand side with n. Again you associate nfx I cap, nfy j cap, nfz k cap. But here, since n is a number, okay, therefore you associate it with the magnitude. You do not associate it with the directions. Therefore, the new force or the new x component will be nfx I cap, the new y component will be nfy, and the new z component will be nfz. Okay, and then you have a force that has the magnitude that is n times the magnitude of the original force. The magnitude of the original force was square root of fx square plus fy square plus fz square. This is the magnitude of the original force, and the magnitude of nf is then going to be square root of n square fx square, n square fy square, n square fz square, and you can take n square common, and out of the square root then you have fx square fy square plus fz squared, so which is n into magnitude of f. So this gives you simply a force which has a magnitude n times the magnitude of the original force, and the direction of the force all remains same. Okay, so this is, I think, clear for this video, and in the next video we are going to talk about the scalar multiplication of two vectors, which is known as the dot product of two vectors. Okay.